Hi everybody, it's really good to be here. I'm sorry I'm the last thing before lunch. I'll try not to go too long, but I really appreciate everyone turning out today. As you said, I'm Brent Cook. I worked on a lot of interesting stuff. I guess you could say I'm a jack of all trades, maybe a master of none, but actually some kind of cool stuff that I've worked on in the past. I worked at Breaking Point Systems. I worked on the networking stack. All the firmware, the TCP/IP stack. We were one of the first people to be able to do 10 million simultaneous TCP connections in a single box at a rate of over 1 million per second, and this was over 10 years ago. I've also worked at Calzeta. I worked on the IPMI firmware, so if you've ever hacked IPMI and found vulnerabilities, that might be a little bit of my code. Unfortunately, they actually went out of business about 3 months after I started working for them, but it was fun while it lasted. Also, I work on the Metasploit project, which I've actually kind of been tangentially involved with for over 10 years, but I really got started about 3 years ago when I joined Rapid7 and became the manager for the Metasploit project. Oh my gosh, it's so dark. Let's see. So if you don't know what Metasploit is basically an exploitation, payload management, pen testing tool, red teaming tool, a research tool. It does a lot of different things. There's a lot of sort of key components to Metasploit that make it work. This is actually, if you can't tell, it's just a screenshot of Metasploit running. It's got a command line prompt, and it can do a lot of different things. It can simulate all kinds of servers, all kinds of network protocols. It can also, of course, do exploitation, meaning it can target vulnerable software, get remote code execution, and then allow you to pivot and do extra things like extract data from a remote system, move further into a network, that sort of thing. And this is basically a talk about what we're doing towards the future to sort of take that big monolithic application and break it up into something that can be used in a lot more scenarios than we're doing today. Ways that we're trying to help people who use Metasploit, whether it's a security researcher or if it's someone who is just doing a red team or a pen test or something like that. Basically, we're trying to make Metasploit a lot easier for our users to utilize, to scale, and to make it better. Talking a little bit about the Metasploit monolith, the idea that we've got here moving forward is to basically break Metasploit into lots of little pieces. You can't really tell this at the moment, but those are little hearts around each of those little Metasploits. There's not a whole lot of grayscale in the projector. But basically what's going on here is we're going to be breaking Metasploit into a lot of little pieces. Not to worry, it pretty much manages itself, but I'm going to be talking a little bit about some of the progress we've been making, breaking Metasploit into different pieces that can be better reused, better developed, and basically make the whole thing work a lot better and easier. Talking a little bit about what's like to work on the Metasploit project is kind of interesting. The project's been around over 13 years, so it means that it's gained a lot of, let's say, loyal followers and a lot of interesting quirks. And this is a comic I like a lot where basically someone was talking about fixing a bug where their CPU overheats every time you hit the spacebar, and then someone basically used that as part of their workflow to be Emacs control character. And so this kind of like what it's like working for Metasploit. Almost every bug that we have is actually part of someone's workflow. So we have to sometimes be careful and sort of get an idea for like, all right, so you're using it this way, but we really wanted you to use it that way. How can we sort of meet in the middle and compromise and improve things while still not breaking everyone every time we make a change? So I'm going to talk a little bit about some of the key features that we're trying to improve within Metasploit, and some stories around why we're trying to make these sort of changes. One of them is around collaboration. Within Rapid7, we actually have a big pen testing organization. They, basically customers will pay us to go and break into their networks and see how far we can go. One of the biggest issues that our pen testers have is around how do they share information between each other. They use a lot of different tools, not necessarily just Metasploit, but sometimes it's custom things that they build themselves. Sometimes it is, of course, Metasploit itself. Sometimes it's like Nmap and Python Responder and stuff like that. And the question is, how do they share all the information that they've collected over time? These days, you use things like spreadsheets, shared chat rooms, things like that. And it's kind of cool that they're using this sort of collaboration tools, but it does mean that sometimes data gets lost, and there's not always a good way to know who's doing what, when, and what basically happens when things go wrong as well. So basically, some of the workarounds people have been doing have been, just writing log files, having someone sort of monitor what's going on, but it doesn't really provide that kind of real-time assurance about what's happening like during a pen test or a red team engagement. Another thing that sometimes people run into is you'll be inside of a network and you'll touch that one box that was really critical to an organization, but you didn't know about it, and it just blew up, and then they go, oh my God, what were you guys doing? And maybe there's 2 or 3 pen testers working at the same time, and they're all like, oh, I don't know, I was just scanning the network, and I was like, oh, I don't know, I was just on the domain controller extracting all the hashes. And so there's a lot of stuff going on, and allowing people to basically have visibility into like what's happening during an engagement is really important, and you don't want to lose any of that data. So basically, and I forgot to mention this earlier, a lot of the projects that we've been building within Metasploit have code names based after gargoyles. I don't know if you guys know the Gargoyles TV series, but basically we've been using them to sort of give us working names for the different projects. The project that we've been working on as far as data collaboration and sharing is called Goliath, and so this is actually the Goliath gargoyle from the TV series. What we've basically been doing is we built a distributed database that allows you to actually store all your results from all your different tools as they scan things in real time. We've also built a web interface on top of this that allows you to immediately see as soon as something gets collected or a box gets shelled or something like that, it actually just pops up an immediate notification. So everyone is always informed about what's going on all the time. This is a pretty cool thing in that it also allows multiple Metasploit users to collaborate over a shared database. Now, Metasploit supported like a Postgres database for a long time, but it's difficult to share that across multiple machines. Usually it's something that's local, you want to lock it down, you don't want to put Postgres right on the internet. But basically what this does, it creates a JSON REST API that's authenticated, and not only can you hook Metasploit up to this database, you can actually hook Metasploit up to multiple databases. So let's say you're working locally on your box, and then one of your pen tester friends says, hey, can you help me out with this thing? You can actually connect to his data source and see what he's doing at the same time. You can connect to multiple things simultaneously and actually copy data between the multiple instances. So it's kind of like the way before Git and before distributed version control systems, you usually had sort of that single point, that single server that everyone sort of shared for collaboration. What we're basically doing here is we're making pen testing a distributed database type system, a distributed pen testing type situation. So give you kind of an idea of what the block diagram looks like. Goliath is basically around the notion that you have these little sort of distributed databases that you can spin up wherever you want. You can put them in AWS, you can run them in the cloud, you can run them locally, and then of course you can have multiple Metasploit consoles connecting to them all at the same time. I've got a short demo. I might save it to the end that sort of shows all this stuff in action. I think it'll be very interesting, but I'm going to hold it to the end just to make sure we have enough time. It'll take about 4 minutes. But I actually do have it on a YouTube page if you guys are interested and want to sort of watch it in real time. And of course, if the projector makes it kind of hard to look at, you can of course look at it offline here as well, and I'll pop that up a little bit later. Something else we've been working on Metasploit 5 is the notion of being multilingual. And that doesn't just necessarily mean Unicode support and be able to support, Chinese or Japanese or Russian or whatever it is. We've of course been doing a lot of that work too. But the idea around here is Metasploit is traditionally, Metasploit 2 was written in Perl. That was about 10 years ago. And then Metasploit 3 and 4 were both written in Ruby. Ruby's a really cool language. It has a lot of really neat features. Unfortunately, it's not really the favorite language of the InfoSec and the research community. I would say probably Python is really like 95% of what most people write a lot of tools in. So the question is, how do we, inside Metasploit, which has thousands of modules written in Ruby, how do we support other languages that people want to write things in? If you ever follow, like, say, ExploitDB or other projects that follow vulnerability, that basically publish proof of concepts, a lot of times the proof of concepts are written in Python in the first place. So a lot of times the big effort that's required to get something in Metasploit is first, how do you write it in Ruby? Sometimes you have to port, you have to reinvent the wheel. Sometimes you have to port whole protocol libraries across to Ruby. It can be kind of a pain in the butt. So what we've basically done is we've added support to Metasploit for actually dealing with any arbitrary language you might want. The project we're using here is called Coldstone. Coldstone is another one of the gargoyles. I don't actually have a picture of him right here, but he's basically a cyborg slash, organic sort of a hybrid. So the idea here is that we've got basically a hybrid system where Metasploit can basically, rather than running modules as a in-process Ruby class, instead they actually run as external processes. One really cool thing about that is not only can you write a module in Python, you can write one in C, you can write one in Erlang, you can do whatever you want. The other kind of cool thing about it is that the modules actually can be easily ported from proof of concept to Metasploit in just minutes. And I'll show you guys an example of that here in a second. This kind of gives you sort of an idea about how Project Coldstone works. And in fact, this code is already in Metasploit. It's been there since about April. We actually had an April Fool's joke. We were going to sort of joke that we had added Python support when we actually did. We decided not to joke about it since people might take it not take it seriously. But the idea here is we basically have this kind of architecture. Metasploit sits in the center. Modules, rather than being loaded in memory as Ruby classes, instead they run as external processes. And I'll be sharing the slides later, but you can see that this is actually a separate process. Basically, there's a JSON RPC interface here over standard in, standard out. So basically, Metasploit creates a new child, talks to it over standard process pipes, and this allows us to effectively pipe to pretty much any sub-process you want. There's a SOX5 proxy that we're building right now that will allow all the networking data from the module to be piped over a tunnel. So if you want to pivot a module into a network rather than hitting it straight from Metasploit console, you can do that. If you want to bounce it off some sort of endpoint or some sort of intermediate device, that'll be possible. That's one of the reasons why we originally had everything inside of Metasploit proper, is because we had the special socket abstraction that allows a module to be pivoted through. This allows us, the SOX5 proxy allows us to pivot basically any process that you want. Either you can use it by injecting some sort of like a SOX module into your language at the lowest level. It's basically sort of monkey patch the SOX primitives, or you could do some sort of LD preload like shadow SOX and basically redirect all the network traffic at the C library level. I'm going to show here a little quick proof of concept of porting a module straight from vulndb, exploitdb, I'm sorry, into Metasploit. So this is a module that attacks the Haraka SMTP server. It's an SMTP server written in Node.js. Actually a security researcher submitted a pull request to Metasploit. We actually didn't realize it, but he basically wrote both a Python proof of concept and he wrote one in Ruby for Metasploit. And so that's actually a pretty good example, so it can sort of show the differences between writing a module in Metasploit as a Ruby instance or writing it in Python. So this is the original Python version. Oh, and that looks not so good. But basically what's going on here, and you can't see it, is we basically just add one line of code, and it's there. Basically, we created a module inside Python that is basically, it's just a module called Metasploit. So you basically say, from Metasploit import module. And that's pretty much the first thing you have to do. Whenever you run a Python module within Metasploit, it automatically injects the library namespace into the search path, so Python is able to find it. So you don't have to necessarily install any extra pip install any Python gems or anything like that. I'm sorry, there's not a Python gem, whatever they're called in Python, eggs. And then you add some metadata. This red stuff is metadata. Basically, it's just a big hash. And basically you give the description and like what CVEs it attacks, what are the options it takes, that sort of thing. Metasploit will automatically parse this information. And then the final bit is just this little bit of code here at the bottom. It maybe takes about 10 lines of code to actually implement it. Basically you create a new main method, and it will automatically handle all the RPC calls between Metasploit and your module for you. And what it'll do is basically whenever the exploit needs to be called, the exploit method will be dispatched. If the metadata needs to be extracted, the metadata module will be dispatched. What it basically means is we only had to add about 15 lines of code to an already written Python exploit, and suddenly it was running in Metasploit. Pretty fantastic stuff. In fact, here's kind of a sort of a summary of what we started with. So this was the original proof of concept that was off of exploitdb as 167 lines of code. The Ruby version for Metasploit was 225 lines of code. And then when we actually ported it to run as a Python module within Metasploit, it was only 106 lines of code because we were able to delete actually some of the infrastructure out of the original proof of concept for doing option parsing and that sort of stuff. So it's kind of interesting in that the Python version of the Metasploit module is half the size of the normal Metasploit module. So the idea here is it's going to be a really nice productivity gain for a lot of researchers and developers. Something else we've been working on, which is kind of cool, is the idea of being able to share sessions between multiple users. Sometimes when you have we deal with all kinds of customers, from tens to a quarter of a million people inside their organizations. Sometimes people have millions of boxes within their networks, which is kind of surreal. But sometimes in those kind of big situations, you have an issue where you actually want to sort of pipeline your red teaming. You have some people who are basically getting access. You have other people who are then taking that access and going further within the network, sort of like a pipeline team. And we wanted to basically make it easier for those kind of people to share sessions. So basically, once you get access into the network, how do you hand off those shells to other people to be able to collaborate with? Some of the workarounds people have done in the past is, of course, run Metasploit like a screen session. We do have like a transport command where you can redirect sessions from one Metasploit instance to another. But these are all kind of awkward and they're a little bit dangerous in that you can easily lose a session along the way. Also, sometimes you want to be able to sort of have a distributed network when you're sort of simulating a kind of a large-scale adversary. You might want to have multiple command and control servers. Dealing with that is kind of awkward within Metasploit today. But what we've basically done is we created this new thing called Metasploit Aggregator. What it is basically a payload proxy. It doesn't have to do a whole lot. Basically, it does maybe three things. One, it listens for incoming payloads. So basically, if you exploit a box or you get access in some way, maybe it's through phishing, maybe it's through social engineering, some other mechanism, Metasploit payloads can actually all connect to the single endpoint, or you can actually have them distributed, and they will basically park. Once they park, you can later on connect asynchronously to the aggregators through a Metasploit console and see what they're up to. So you basically, multiple people can connect to these aggregators. It's basically like a proxy, and see what sessions have come in. You can disconnect them, you can interact with them, you can pass them between users, but from the outside world, they look like they all are connecting to a single box or multiple boxes. You can actually connect to multiple aggregators at the same time too and get sort of a global view of all the different distributed boxes that you've got running. This is kind of an idea of how the mechanism works, and you can of course check this out. We have this open source as well. The idea is you have multiple Metasploit consoles. They can all connect to the aggregator, and you can have multiple shells. You can have a command line shell. You can have an interpreter, and aggregator is basically the single source of truth for all your sessions that are running through. I would show you a demo, but we added a really cool new feature about 2 weeks ago that broke aggregator. And that's actually a good thing. Sometimes when we build features with Metasploit, we discover that there's actually maybe a weakness that we discover along the way. In this particular case, aggregator was acting as a man-in-the-middle proxy. What that basically means is it would intercept all the traffic that would go to normally to Metasploit, man-in-the-middle it, and then would forward it back to another console. In thinking about that, that basically means that all Metasploit sessions are man-in-the-middleable. Not necessarily a good thing. So we actually recently added support for end-to-end encryption between console and a interpreter shell. What that also means is that we broke aggregator, because now aggregator can't basically intercept the session anymore. We're working on ways to make aggregator actually smarter and able to actually implement full end-to-end encryption with itself as well. But in the meantime, it was kind of a fun problem to have, in that we actually broke our own code by making the other code better. I'm going to talk a little bit about that sort of end-to-end encryption and other things by sort of segueing into all the improvements that we've done to payloads and that we're planning to move forward with in the future. One of the sort of notions, and actually this is the reason why I started at Rapid7, was because they wanted to get interpreter payloads running on everything. And by everything, I mean your watch, your router, your switch, your phone, all those sort of things. And I've worked on a lot of embedded devices. I kind of have some experience with building things that run kind of everywhere. And this year we actually did it. I actually have a talk I gave at Nolicon 2017. You can check it out on YouTube. There's a video. It takes maybe an hour to watch it. But basically what we did was we created a fully portable Metasploit payload from Interpreter that can run on an iWatch. It can run on FreeBSD, OpenBSD, Solaris. We've actually got binaries for it for OS X and for, I think, 11 different architectures of Linux, all the way from mainframes, S390, to oddball ARM variants, to printers. It's kind of cool, and we've had a lot of researchers say this is the first time we've been able to actually show like a real working exploit chain with my proof of concept. In fact, one of the reasons why we actually got these payloads pushed out in the first place was because of stage fright. The stage fright vulnerability that Joshua Drake, JDuck, discovered, I think a couple of years ago now. He was actually trying to build a working proof of concept because there was a lot of fear about, oh, this could be easily exploited, but no one was actually able to get it to work in kind of a practical sense. One of the reasons why it wouldn't work was because of SE Linux. SE Linux prevents, at least within the media server context, prevents you from actually doing a fork exec. Traditional shell code, you think binsh, you're going to actually execute binsh, connect to a socket, and you're done. That wouldn't work within the media server context because of the SE Linux restrictions. So Josh came up to me and said, hey, I have to combine this with a kernel exploit to make it work. Could you help me out and build basically a payload that would be able to do a lot of things, but without ever having to fork or exec? So we basically built this payload, and I talked about a little bit, that can be injected into a process and can do basically everything you might want to do within a payload, whether it's looking at files, taking pictures with the camera, whatever. It's able to do all these things, and it never forks, it never execs, it never even has to write to disk. So there's actually some pretty cool stuff. If you want to check out this talk here, we go into a lot of detail on how that all works. We even have a special tool chain that actually builds magical binaries that are what you call static pi binaries. Basically, they're sort of a combination of a dynamic binary, so it can be relocatable, but it's also static in that it's fully self-booting and doesn't have any external dependencies. That's something we actually got out this year. It's not necessarily a Metasploit 5 thing, but it's something we hope to continue extending in the future. Of course, the other thing that we're working on is encrypting everything. When you're a pen tester or you're in a red team or whatever, you want to make sure that even though you're exploiting vulnerabilities or you're finding weaknesses within your targets, you don't want to yourself create more vulnerabilities than you discover. It's easy to be careless and sort of lose data, or you don't want someone to be able to passively sniff it or basically transmitting things unencrypted. So what we've basically done recently is we've added this idea of what we call crypt-TLV. Under the covers, Metasploit Interpreter uses a transport protocol we call TLV, that's short for type linked value, kind of a boring name. But the basic idea here is that everything that you say to interpreter sessions or that they respond to all have the same sort of unified packetized response. Normally these packets are unencrypted. What we've basically done in the most recent revisions is rather than relying on the outer transport, whether it's HTTPS or reverse TCP using TLS, we basically added application level encryption support. So basically, the very first thing now that happens with the interpreter session is that there's actually a key exchange at the application level. And then this can actually be layered on top of multiple on other encryption as well. So you can basically do application level key exchange plus AES 256. And then on top of that, you can tunnel that over at TLS or whatever. But the idea here is that no matter what your underlying transport protocol is, whether it's plain text or not, you will still have that sort of confidentiality and that encryption support built into the interpreter sessions. You can actually check out the PR up here. It's pull request number 8625. It's got about, 20 pages of description about how it works, what are the caveats and that sort of thing. The other kind of cool thing here is that we no longer rely on OpenSSL within interpreter payloads. We used to actually bundle it in because we weren't necessarily able to guarantee that we would have all the low-level primitives we need to do TLS encryption. Since we're actually kind of rolling our own encryption, not necessarily a good thing, but it's kind of the best thing at the moment for our use case. It also reduced the size of our Metasploit payloads, or at least Windows interpreter, by 5 times. So rather than being a megabyte, I think it's about 150 to 200K. So pretty cool improvements there. Pivot everywhere. Traditionally, Metasploit payloads have basically been defined, what we call a session, as a connection from point to point. So basically, if a TCP connection comes in, that's a single session. If you want to pivot a session, which basically means how do I move from one session to another session within a network, you had to create what's called a network tunnel. So you'd sort of tunnel that TCP connection over another TCP connection. If you wanted to tunnel a second time, you'd have to tunnel another TCP connection over a TCP connection over a TCP connection. And each tunnel would also independently ACK and each packet that goes across the network. What this basically meant was we had a sort of it's either a geometric or an exponential increase in the number of packets sent for each hop that you made. It also meant that if you lost a TCP connection, you'd lose your session. You would lose all sort of accounting for it. And this wasn't necessarily a good situation. So what we've done is we've actually made it so that sessions can be pivoted. We basically added enough session identifier information to the low-level packets, the low-level messages that go across, that they can actually be tunneled directly rather than over requiring a specific TCP connection or some sort of other network connection to identify them uniquely. One kind of neat side effect of this, and this is semi-intentional. I'm sorry, this is again kind of a low-quality screenshot here, but we can actually tunnel over things that are not TCP now. For instance, this actually just landed 2 days ago, but this is a named pipe session. So basically the idea here is that we've got a box on the edge of a network that has a reverse HTTP connection back to Metasploit. And then from that point, you can actually pivot into other boxes within the network, not using TCP, but using, like, say, SMB, or using, in this case, we're using a named pipe, which is kind of normal traffic that you'd expect to see on a Windows network. And so it won't look nearly as weird, and it's using basically all the same low-level primitives that you'd expect out of Windows. So this is actually an example of 4 different interpreter sessions being tunneled over a single one with no extra latency and no extra delay due to extra tunneling encapsulation. So it's some pretty neat stuff. We've been working on it actually over a year to get all the primitives built in, but now that it's finally in, I think it's going to be really other people have done this sort of technique before, but it's the first time we've had it in Metasploit, so I think it's going to be really interesting for pen testers and red teamers to use. Extending and expanding. So while a lot of these cool things are interesting, we sort of have a problem with Metasploit, and it's not a huge problem, but Metasploit is open source software. It's basically under like a 3-clause BSD license. But sometimes we want to use other software at the same time with Metasploit. And the BSD license needs to stay BSD, but sometimes we see other software like GPL or Apache or something that may not be as compatible as we want. The question is, how do we possibly use other sort of software with Metasploit without sort of violating license terms or sort of breaking the spirit of what people want their software to be used for? The reason why this is kind of interesting is because actually it came up fairly recently is we wanted to be able to play sounds through Linux. And you think that was easy, but it turns out Linux has had about 5 or 6 different audio APIs over the years. So supporting all these APIs directly, especially when you want to target sort of in a general sense a lot of different Linux distributions and a lot of different embedded devices, can be difficult. But there are some nice libraries out there that actually let you do it. But those libraries are GPL. So the question is, how do we possibly use some of these things to our advantage? Other issues are sometimes we want to be able to target different ABIs, especially when it comes into the embedded space. You might have 2 or 3 different C libraries that are actually in use. You have glibc, you have musl, you have microlibc. I think there's probably a couple others that are available for Linux. So just because you've targeted Linux glibc doesn't mean you work everywhere. So the question is, how do we sort of bridge that gap? What we've come up with is basically the idea of being able to extend Metasploit with extensions written against different libc ABIs. And not just different libc ABIs, but we can actually sort of cross a license boundary by being able to build extensions that are running as child processes rather than embedded into memory. What this basically means is now we can actually have a hybrid approach where we can have a single process, or at least a single tree of processes that can talk both to the native system libcs. So like, for instance, say you want to talk to dbus on a local Linux system and sort of snip what traffic's going on there. You could talk to glibc, talk to dbus over a extension based on an injected process that's using metal. And metal, I forgot to mention, is actually the embedded payload that we worked on and is talked about a lot in that Nolicon presentation. And then, of course, you can tunnel that back to the Metasploit console. So there's a lot of really cool stuff here. This one isn't actually out in public, but we should have it out pretty soon. And I think it's going to be kind of a